All right, so especially for our ill friends, 1, feel better. 2, stay away if you're not better. 3, love you, but yeah. So, and this got dragged, I don't know why. All right, so we're going to move this up, and I'm going to run you through what you guys are doing, and then just kind of let you roll. So in 611 and 612, we played with those Desmos activities, or actually, I forget if they were straight through Desmos or through CPM. We played with those activities to kind of look at our rigid transformations, right? So we talked about the differences between like a translation, a slide, a rotation, right, a turn, a reflection, like flip, and all of those still preserve the same size, right? None of those change size. Anyone remember that word that I told you guys means to change size? If something is transformed and changes size. Starts with D. Yeah, scale, it gets involved. A scale factor would be involved. But the one word that describes changing the size of something. When you go to the eye doctor, they do this to your dilation. So that's what you want to remember when we start thinking about changing size, is the eye doctor. The eye doctor dilates your eyes. So none of our transformations today should do that because they are rigid. Remember, rigid transformations do not dilate. So what your goal for you and your partner, and potentially a group of 3 if you so choose, is work through 18. Probably going to be pretty easy to figure out how A, B, C, D got over to W, X, Y, Z. Answering these quick little questions. Then move on to 19. Talking about this point was translated to that point. How did that happen, but don't graph it? You don't want to graph this. Your x-axis would have to go out to 32. That would be ridiculous. So you don't want to graph that. So, pay attention to that. But then once you figure out what happened here, you apply that to another point. In 20, you and your partner want to decide what sort of rigid transformation made this happen. And pay attention to the order of the points. This is going to start to matter a lot. And guys, I know I'm throwing a lot of information at you, but then I'm just going to release you, so I just need you listening right now. The order of the points matters. Okay, so if you say C, D, E, F goes to S, R, Q, P, that is different than saying it goes to P, Q, R, S. What this means, the order tells us C goes to P. D goes to Q. Line DE relates to line QR. Does that make sense? That the order of the points is fixed between the pre-image and the image, right? The result after. Then 21 tells you that something got reflected and, what happened, and we analyze that. And then 22 and 23 kind of extend on that. If you make it to 24, awesome. It's another one of those key problems like what we saw last week. And yeah, then the additional challenge. So any questions before I just let you guys dive in? I am trying very hard with the new year and whatever else on 2019, and just because we're in the second half of the school year, I know you guys, and you guys are a bit more comfortable. I'm trying to do less spoon feeding, right? Like a baby can't chew their own food and they can't even get it to their mouth. And I'm trying to set back and say all right, here's the food, go for it. Seriously. Yeah, here's some stuff. You get the knowledge in your brain. Get the So please stick up a hand if you're struggling while you're working through this, but I'll probably just be kind of meandering through the classroom. Dive in. Sure. You could have if you were done with the test and everything. So essentially, if you get to a point where you're done with this, you're just doing the practice, and if you've already done that, you can move on to the next practice. I'm going to show you guys again where we are going as soon as I find that spreadsheet, because I had printed it. I could post it somewhere. I don't want to print a bunch of copies. Yeah, I'm thinking about starting to utilize Schoology more since you guys are comfortable with that. Yes. Now I will also keep mine up there. Again, I want to encourage anyone in here who might be thinking about coming to math counts competitions. Do it. It's this Saturday and then 2 weeks from this Saturday.
Even if I wanted to, I couldn't.
Wait, so the scrimmage is on Saturday?
The scrimmage is on this Saturday. Anybody can come.
Even if I did want to go, I can't go because I have honor band Saturday.
Yeah, I'm sorry.
Oh,
That normally does end up conflicting. There's just not enough weekends in the winter.
You didn't go to the actual honor.
no, we got into like a different honor band. We got into weekend.
All right, I might have given that to somebody.
You didn't go to the only
Real quick, just to recenter, because I hear some conversations going astray. Is this a reflection, a rotation, or a translation? It is a translation. The shape does not rotate, does not change in any way. It is still oriented the same. So you're trying to figure out what happened that made A go from -2, -1 up to W. That's what we're trying to figure out first. That's fine. We're going to review and push you forward. Who thinks they can describe the translation that occurs here? Really?
Wait, so I'm just going to say 18. Okay, it was translated because it was not.
Yeah, but what is the
Oh,
translation?
so before it was 8.
Oh, that's the same thing.
George?
So for the, not that one, but the other one, it would be so you move 6 to the right and 8 up to get to from A to W.
Do we agree? 6 to the right, 8 up. So we could write that. My smartboard's all goofed up. 6 to the right could be x plus 6, right? And then 8 up could be y plus 8. So then when we move on to the other problems that ask us, so what about a different point? We know whatever the x is, just add 6 to it. Whatever the y is, just add 8 to it. I'm going to fix my smartboard. You guys keep moving on. It's not centered. It was just long weekend.
That shape right now.
One time I went to Caribbean, one of my friends went to Rowan transformed the plot to like about CD.
Yeah, I paused it for a little bit. Yeah, that's why it's not, like, it's only done 8 minutes of recording. But it is, my screen got shifted around a little bit. My recording screen. I don't exactly know why.
No, it's not possible because it's not translated. Oh! I get it.
When you go to write a translation, also because I hear a lot of off-topic conversations, which makes me feel like I need to choose your pairs. Again, this is up to you until it's not. I don't know what I just did. We want to write our translation x, and then what happens to it, comma, y, and then what happens to it. In 19, what happened to x? 28, right? It got added. 28 got added to the value. What happened to y? It went down by 9. We can then use that to move our new point. Right? So with that -16, we're going to add 28 to it. With the positive 9, we're going to take 9 away from it, making the new point, which we would call the prime point, or we just rename it with something else, becomes 12, 0. So you should be through 19 at this point, even if you didn't get there on your own. We just went through what 19 is on together. Now, is 20 a translation?
No.
No, and we can see that because point C corresponds to point P. And this, I'm really trying to let you discovery learn. Analyze what happens to the point, like the values, the numbers, with this reflection. And then they push you to say, what would happen if it reflected on the X? And then when you get onto the rotation question, I really want you to be writing things down and analyzing what happens with the numbers. We chatted really briefly about the rules. Remember I threw those rules up there and I showed you sometimes the numbers switch places, sometimes they become the opposite as they were. So analyze that as you go. Keep rolling.
It only.
Wait,
It's
can you flip? That's too much
Kind of like a mirror, right? Keeps everything the same, but looks like it is the backwards of what it is.
Well, you know the quadrant is
Where does C start? -7 what? +6, right? And P becomes... So, when... Give me your attention real quick. When we reflect the y-axis, does anything happen to the y? No. What happens to the x?
It
becomes the opposite. So if we reflect the x, what do you predict will happen? Quinn?
The x or the x value. The y values would change, but the x values wouldn't.
So we're predicting this would flip down over here, and the new point would be, you said x wouldn't change, and y would become
The opposite.
-6.
Yes, I actually did.
Or over here, if I grab P and reflect it, that would be 7, -6. So we can establish, because I want to keep pushing us on a certain timeline, we can establish a rule, or I guess rules up, when reflecting an axis, x or y, just one. That point, that part of the point, doesn't change, and the other part becomes the opposite. Right? So we can go ahead and establish that rule. For everything we've seen, this works. I want to push you to make your way down to 21 and 22, because that starts to make you analyze the rotation and what happens to the points when we do that. Connor?
Yeah, but can't you times those values by turns both x and y by -1 and can interpolate it diagonally.
So going from this point down to here, you mean?
Yeah.
I would ask you, what line does that reflect?
The xy.
So if it reflects both, and we're not quite there yet, but if it reflects over there, that line that it's reflecting on would probably need to run kind of like that, diagonally across. Now we're going to experiment with that stuff as we go further into this. But yeah, I think you might be onto something. Why? Why? Why are you this?
No.
All right. Y-axis.
Oh my god. Oh yay.
Now we have to. Use your hands. Your hands are wonderful. I need everyone to shift your attention to 625. And we're going to talk about this together real quick. So, I want you to write down, real quick, and shouldn't take any talking, what I have on the board. You don't have to draw the graph, but I want you to write down positive rotation, which you can abbreviate if you'd like. Positive rotation is CCW, is counterclockwise, which is weird. For us Americans, we tend to think of a positive rotation being turn it to the right, because that like tightens things for us. That is not how it works mathematically. If you put something else under, it's because the desk and like it's migrating. Yeah, so you put something else under it. So when I look at turning 90 degrees, and actually if I draw one more of these, we'll have like a cool little windmill looking thing. If I look at going 90 degrees, I take this point that's at -3, 0, and this point at -3, 1, because I know the point on the origin isn't going to turn. It stays there and pivots kind of around that point. So anyone play basketball in here? I don't think. Yeah. Are you playing right now?
Yeah, practicing.
You gotta let me know if I can come to a game and like, take pictures. And
Oh, we
stuff.
don't have games in a room.
Oh, you're like WYB.
No, it's doing sport.
Ah, okay. So if you play basketball and you don't want to get a traveling foul,
Oh yeah.
you can't like just hold the ball and like that doesn't work. But you can hold the ball, plant a foot, and do this as many times as you want to, as long as one foot stays planted. That's your center of rotation. It doesn't move, and that's how you avoid your traveling. Where does -3, 0 go to? What does it become? Because that's this one, right? Pivot down. What's that point location? 0, -3. So what does it seem like happened to my points? They swapped places. Now hold on, let's test it with my other point, -3, -1. Where is that new point?
Oh yeah.
It just flips.
Isn't it?
It
Oh.
changes the values.
So what happened? Connor?
They kind of flip, but the negative and positive don't always stay the same.
So the x value took the place of the y,
Yeah.
and the y value, Mallory? It became the opposite, right? Let's try this just with a random point. Trust me, I know. So if we go, let's go -3, +4. That's why I'm not like rushing us and why I had you guys like play for a couple days. -3, +4. If I hockey stick out to it, and then turn my hockey stick, 1, 2, 3, that point ends up at -4, -3. Did the x take the place of the y? Yeah. Did the y become the opposite and take the place of the x? So for a 90-degree rotation, however you want to write this in your notes, x and y switch places, and the original y becomes the opposite. Do not say positive or negative. You need to use opposite because you never know what we're going to start with. Guys, I have some people not writing. You're not going to remember this. Micah?
Does that only work when the center of rotation is on 0, 0?
Yes. And I know in those activities, we had some that were not centered at 0. Most of what you're going to be doing, like pretty much everything we expect you to do this year, is centered at 0. They wanted you to be able to visualize rotations elsewhere, but most of what we do centers at the 0 to get you guys comfortable with this. But the hockey stick method will work no matter what your center is. But these rules, to make rules, we got to be centered at 0. Yeah.
Yeah, that's 90 degrees on 8, but what if we're like 1 or 2 or 3 degrees?
There's no easy rules for those. Yeah, there's no easy. If we go degree, like 10 degrees or 20 degrees, that gets gross. We can do it, but that's normally where you would use a computer. Yeah, where you would use technology. So then for a 180-degree rotation, this point becomes this point, right? So -3, 0 becomes +3, 0. So what happens to -3, -1? This point right here. Excuse me, +3, +1. What's your hypothesis for what's happening? Braylon?
They both swap. No, they both switch to the opposite.
I like your second description. They both switch to the opposite. So we're going to try to formalize these rules. What I would write for you is CCW rotations, like counterclockwise, 90 degrees starts at XY and became the opposite of y, x. Now this doesn't make this x, but whatever your x started as now goes here. Whatever your y started as becomes the opposite and goes here. For 180, and I know I switched colors, sorry, I kind of flipped things around on you. For 180, which up there's red, sorry, I should have really thought this through. Braylon's saying they both become the opposite.
What about 270?
If this switch,
If in a 90, we swap places and take the opposite of y without testing it, what do you think will happen with a 270? Braylon? I agree. So I said if we make one more of these, we'll have a cool little pinwheel. Let's do that. So if I rotate this 90 more degrees, here pointed out, this original point of -3, -1 comes out to here. So for 270, I don't like that the color reset. So we said -3, -1 becomes, ooh, wait, -1, +3. So my x, y became y negative x. Notice how those rules compare. In both 90-degree rotations, because technically 270 is 90 the other way, they both switch places. But in the 270, your x flips its sign, becomes negative, versus your y. So be careful with what direction. Make sure to think through, does it actually make sense? And be ready for a rigid translation mastery tomorrow. Probably just mini. So the comparison of 90 between 270 is in 270 the x is what becomes the opposite, and 90 the y is what becomes the opposite. It turns around. Yeah, if you go clockwise rotations, it's the exact opposite.